final slide there for me. I'll run through a quick recap of our housekeeping notes here. So again, we're going to track attendance. I noticed a lot of you have already put your names in the chat box. For those of you that haven't, please go ahead and do that now so that we are sure to credit you for attendance. Oops, runaway PowerPoint presentation there. Again, seemed to work pretty well yesterday, but let's shoot for a first version of questions in the chat box as well. And as time allows as we go, Tim may ask. Ayrton, our animation there is too effective and forceful, apparently. So questions in the chat box, and we'll do our best to make sure that everybody's questions and comments are addressed as we go, or try to follow up after the fact if we just run out of time at the end of the day. Again, PDHs for folks who are looking for that, we'll get certificates out to folks who have passed the cutoff in terms of time of participation within the next 2 weeks. And for those who didn't quite make it there, we'll share some information with you about how to watch the recordings of the videos, or the video recordings of the workshop to make up for lost time and to earn that certificate. So last thing there was a final email that went out this morning with the handouts, copies of today's slides, and also the corrected, I believe it was module 2 from yesterday. So hopefully everybody got that. If not, once we're out, check your spam or junk email folders just in case we got misrouted there. And we will help you close a gap there if you did not receive the email. So I think, Tim, with that, turn things over to you. And I guess maybe just start out with a question to see if there was any, I can't remember if we had any, unresolved issues or questions from yesterday, or if we're ready to jump into things and take off.
Okay, thanks, Matt. Welcome back, everybody. And just wanted to say, we're just wanted to open it up, I guess, for any questions you have maybe from yesterday's material. I know we covered a lot of things and kind of set the stage, I guess, if you will, for really getting into more of the details and specifics of not only just setting speed limits, different tools about setting speed limits, but also some of the countermeasures that can be used. And then we're going to be wrapping up today with looking briefly at some of the other E's, specifically enforcement and dealing with stakeholders, public policy, all part of the, I guess, the education aspect of one of the other E's. So if you have any questions, just feel free to throw them into the chat area. Or at this time, if you just want to unmute yourself, I think we can try that and see how that works. So again, if you have any questions, just throw it out there. What we're going to do here in a short time, if we do have some questions, we'll certainly address those. But then we're going to move into the case study and kind of finish up with the case study we left off with yesterday. Any questions? Just give you a moment to think about anything that's really just burning or gnawing at you that you may want to ask about yesterday.
Hey, Tim, I'll throw one out. This is Matt.
Yeah.
You talked a little bit yesterday about the relationship between operating speed, design speed, posted speed limits. I've always kind of had this theory, or I've developed a theory, I guess, or outlook on things that once the road is built, a lot of those things are not completely set in stone, but they're very difficult to change. Once the roadway exists, it's taken form. Do you think we're going to see any change in that, or are we still probably looking realistically at physical changes to the roadway in order to really have an impact on behavior?
Well, that's a great question. I guess a few things I'm thinking of about that is, going back to the design, I think it's imperative that we relook at how we design roadways. I think for decades, we've pretty much designed roadways, you know, motor vehicle centric type of servicing. And I think there's a groundswell of support for, I think, relooking at that. And I think the Green Book, from what I hear, changes are going to be coming in the Green Book that will address some of those issues as far as, you know, functional class and being more, I guess, complete streets minded in terms of design aspects. But I tend to agree with what I think your general, I guess, philosophy you're alluding to is that once the roadway is built, you're pretty much, you know, it's like the, you know, the concrete is pretty much set. There's a few things you can do to, you know, tweak it or improve it, but your options are fairly small in terms of the overall impact you're going to have, unless you go back and do some, you know, some changes that may include things such as road dots, you know, bulb outs, things like that can help to reduce speed. But your best opportunity to manage speed is really at the planning and design stage. Once you get to the operations and maintenance stage, you're dealing with operating speed. You know, your toolbox is less. Maybe you may have more tools in your toolbox, but the impact that those tools can have, I think, are going to be less compared to what you would have at the design stage. It's not to say you can't make improvements. You certainly can, and that's where, of course, the other E's come into play: education, enforcement, and, you know, emergency services. Those things are going to kind of come into play more so than they certainly would at the design stage. So, but yeah, overall, I think I tend to agree with that overall philosophy, I guess, that you're trying to communicate. So I think ultimately it's going to come down to, we're going to have to make a hard turn, even though it's going to take a little time. I think we're going to make a hard turn, you know, turn the ship in a little bit different direction to start addressing those not just needs of all road users, but I think just the needs related to, you know, managing speed better. Great question. Okay. Any other questions?
I haven't seen anything in the chat box.
Okay. All right. Well, I'll give you another moment here, and I'll start to pull up some information, and we'll jump back into where we were. Okay. When we left off yesterday, we were talking about a project that was in the northwest corner of Alabama. It was it's basically a new alignment for Alabama 157, State Route 157, which is which became a second major crossing over the Tennessee River. Before this project was built, it was basically one primary arterial US 72 over the Tennessee River. So had a lot of routes kind of converging in this area with the single river crossing on Alabama 172, aside from the 2-lane road you had over the Wilson Dam. So we were going to look at this. We went through these slides yesterday and looked at the old Wilson Dam road, just simple 2-lane road. And if you recall, it went over the Wilson Dam. I think it was very narrow lanes. Speed on this over this dam was probably about 20 miles an hour tops. It was very narrow lanes. I don't know the exact width, but very, very narrow. This is a shot of the new roadway, Alabama 157, the additional river crossing that was built back in, I I'm not exactly sure when that was. It was probably, well, it's been probably 15 years or more ago, roughly. Don't know the exact time frame, but it's been there for quite some time. So you can see here, it's got shoulders, you know, a raised median, curb and gutter on the inside, shoulders, improved paved shoulders, rumble strips on the outside. This is just a shot overhead from Google Earth, Google Maps of the facility. You can see it's a full width bridge with shoulders, 3 lanes in each direction. With actually has the pedestrian protected pedestrian area too over the river. So so what I'd like for you to consider is what are some things, and we're gonna bypass on this, guys, on 4A. We're not gonna use that link, so no need to put that in there. I think just to probably expedite this process, we'll just kind of do it over chat. So thinking about the roadway, what are some things that you would consider to be, I guess, the considerations as far as selection of a design speed? Are there some overwhelming things that would be of concern to you? And to kind of help with that, what I thought I'd do is to revisit a couple of slides we looked at yesterday. This comes from an older edition of the Green Book, but I don't know that this has changed in the latest edition. But regardless, looking at the different functional class, think of how you might classify this particular roadway and the terrain perhaps that was on this particular roadway. It is relatively level on this roadway. It's not, even though it's in an area that is somewhat, has a lot of change in elevation, you know, around the river more so than not. But in this area south of the river, it's fairly level, maybe rolling a little bit away from this particular route. But anyway, it would be considered level. And then another slide we looked at yesterday related to choice of design speed was this suggested target speed from the NCHRP report. So if you think about maybe what's the context, rural town, suburban, urban core, this would probably be considered suburban. I guess you could think of it, maybe it is urban. It isn't an urban, you know, corporate limits, but it would probably be in this urban suburban category. And then again, how would you classify it? Would you classify it as a minor arterial principle or limited access freeway? What are some considerations here that you might use for your design speed? So what are some of the factors in, going back, what are some of the factors that that you would consider in terms of the design speed? So this is it's 6 to 7 lanes. It is has two-way left turn lane in parts of it. It has raised median in part of it. It has both shoulders and curb and gutter. Paved shoulders are generous, you know, 8 to 10 feet. And on the inside where paved shoulders are used, I think they're about 2 to 4 feet. Projected ADTs back when it opened was around, I think, 15,000 a day. Design in the 2028 or something, I think, of that nature, it was going to be about 25,000 or so. So fairly significant, you know, volume. 2% trucks. Some of the intersections with connecting roads were at grade intersections, and there were some that were, I think, at least maybe just one grade separated intersection. So if you would, just throw some things into the chat area that you think would be important in terms of a selection of a design speed. I've got to get back to that. All right, so we've got some people throwing some things in there. That's good. And I'm just going to look at them. You can read them yourself. Question about signals. Yes, there was, I'm thinking at least 3 signalized intersections on this route, perhaps 4. But the entire project, I'm guessing, was about 3 miles or so in length. Again, this is just kind of a rough guess. Don't have those figures right in front of me. But yes, there were certainly signals on the roadway. Crash history, it was a, only a portion of this road was, part of it was new construction, part of it was reconstruction. So there really, the crash history on this particular road would really, I guess you'd have to say there was not any substantive crash history related to the project itself, because it was again, a new alignment. Lighting would be a consideration. Got geometry access, ADT access. Okay. Right. The new roadway is not a limited access facility. It would be considered probably urban or suburban as far as the area. All right, we got pedestrian access, land use, contact needs, complete streets needs. I do not think the signals had any type of pedestrian signal indications. Yeah, I'm not aware of any. They could be, but I don't think it was part of this particular project. Lane width was another good. Frequency of access. Not a lot of access on the southern end of the project. There is some access, a few businesses and things of that nature, some intersecting streets, but not much for probably the greater half of the project. Okay, so what I'm going to do is I'm going to ask Matt or Ayrton to post the link to 4B into the chat area. And if you would, just go to the Microsoft Forms there with using the link and take your best educated guess, knowing what you know about what you would say about the design speed. What would be your, I guess, best guess at a design speed? All right, and let me know if that link's not working, but it should be good to go. While you guys do that, I'm going to switch over. So I'm going to have a little stop share, and we're going to pull up the responses. All right, we're going to see how you guys do on your responses and this. Okay. All right, we got a number of responses coming in. That's good. We're over 30. We need to get higher so we can get some. And go ahead and call this call for the solution of the design speed. All right, so let's see what we got here. Okay. All right, so we've got, looks like the winner right now is 45 miles per hour for the design speed, followed by 50 miles per hour, getting about, yeah, a good number of votes there. And then trailing that is 55 coming in third and 40 miles per hour coming in fourth place. And we have a few choosing 65, 60, and even a 35. Okay. So for those who chose I guess the, which way should we go here? Let's see. So for the ones choosing, we got a group that are choosing over 45 is higher, I guess, than the group that's choosing, let's see. Yeah, I'd say it's pretty close though. The under 45 group is about the same as the over 45 group. So that's interesting that that these responses show the winner is choosing 45, and again coming in second would be 50, and then 55. So going back to jumping back to what we were talking about, those primary concerns you mentioned were things such as access, lighting, lane width, crash history, trying to think of some other things, the curb in the gutter, shoulders, some of the features as far as the context, urban, suburban context. So thinking back about the what's in the green book as far as those ranges, I'm thinking let's just go back and peek at those one last time, see what we got. So still have some votes coming in for that. Let's go back and look at this. So we had for the suggested target speed, I think most everyone would probably say this is a principal arterial. And suburban and urban, if you're suburban, you're looking at 30 miles per hour and above, low to medium as far as development. You're looking at 45 and below on a principal arterial. And if we go back to the arterial level, this is just, based on the terrain and functional class. And urban area, we're anywhere from 30 to 60. So it's not rural. It certainly would lean toward this urban, certainly this urban category. So 30 to 60. So you can see just, based on our responses, your responses to this question, we got anything from basically from 30 to 60, with pretty much the average being what we won out, 45 miles per hour. What was interesting about this particular project, to kind of wrap this thing up in a nice bow here, is that when the project was first opened, it was had a design speed of 45 miles per hour. It was signed at 45 miles per hour when the project opened, and there were some some questions that came in and complaints that came in about the particular roadway section because of the look and the feel of the road. I think most of us would agree you would feel comfortable driving over 45 miles per hour on this particular roadway. It's it's basically a straight shot. It's, in this case, this particular photograph is 7 lanes, and going back to the some of the other ones, it was from this perspective here, 3 lanes. It's again, it kind of, the look and the feel of the roadway I think most everyone would agree would be more than 45 miles per hour. So what happened is the speed study was conducted, and the speeds ranged anywhere from 54 to 63 miles per hour operating speed, with probably the average was down below that, but upper range of 63 miles per hour. So a speed study was conducted, and using the information that was available at the time, the speed limit was changed to 55 miles per hour. So I think the point here is that, again, design speed is not always a good predictor of the operating speed. Now, the target speed is, again, an attempt to blend, to not blend the two, but to design the roadway in such a way that you achieve a desired operating speed. And on this particular roadway, you have to ask the question, is 45 a desirable speed for motorists on this particular roadway, given the context, et cetera? And, you know, some would probably say, well, no, it's really not. It should be a little higher. There are some, I guess, that would say it should be a little lower. But the range of speed that was chosen, this 54 to 63 mile per hour, was generally the, you know, the range of speed selected by the motorists. And certainly as these things, you know, development comes along in here, it's good to change some of this and, you know, more access and things like that along this roadway. There's certainly that, you know, there may be need to do a recheck of the speed, you know, pending, you know, any change that might occur along the roadside environment or the roadway itself. So that's just a little, I guess, deeper look into the difficulty of making a comparison between the design speed and the operating speed, as pointed out yesterday. Okay, so that's pretty much any questions about the particular little exercise we went through there, the case study? Anything that surprised you about that?
Hi, this is Vita from TDOT. I put in a couple chats. Yeah, I agree. When you look at that roadway, you feel comfortable going faster. But I think that operating speed, like you said, was a reaction to the fact that it was a wide open roadway design. Like if the design speed was 45 and that was the speed that they wanted people to drive, could the roadway have been designed to encourage speeds closer to 45 versus saying design speed is 45, but we're going to design it to be wide open so everybody feels comfortable going 55, 60.
Right. I think that's a good point. When you look at it, it's like, well, you know, you could land a small aircraft, you know, on this roadway, and it's, you know, just I think the width of the right of way and the number of lanes. Anytime you have the more lanes, the fast, you know, higher the speed is likely to be. There were just a lot of factors that really were communicating to the driver that the desired speed or safe speed for this roadway is not 45. That it would, for most people, and I think the data bore that out, is that most people were thinking, hey, this is a road for, you know, 55, get from point A to B. This is not a this is a road. It's not a street. You know, back to the Strode video we saw yesterday, that it was designed to function as a road to get from point A to point B, and not to build wealth. Again, going back to the video. But yeah, those are good comments. As far as being some type of failure of the design or implementation process, I would say no, it's not a failure. I think it's just it's a matter of, again, what's the intended speed for this roadway, and then developing the design around the fact of this is the desired speed. So maybe more narrow lanes, maybe less lanes, considering, you know, future build out. You know, was it really a need for, you know, that number of lanes? I think there may be some questions that were certainly could have been addressed, and at the time of the design process. I don't know if they were or not, but certainly some things could have been done, I think, to help achieve a more desirable or target speed. But again, it's always, you know, Monday morning quarterbacks can always, you know, win the game. So have to remember that too. We're a little bit at a advantage looking at it in hindsight. Okay, all right. We're going to jump into the next module, which is looking at different methods of setting speed limits. Is there one tried and true method? Are there multiple methods? And where do these different methods, how do they play out in terms of the when you use them, how you use what, where? All right, so. All right, so in this module, we're going to look at the different aspects of some of the current methods of setting speed limits. We're going to look at some of the injury prevention and considerations of all users, some of those approaches that deal with setting speed limits, such as safe systems, trying to minimize the injury that occurs when crashes do indeed take place. How can we minimize injury by looking at speed and considering all users? We're going to look at the 85th percentile, and some agencies consider that the gold standard, so to speak, and use it strictly, and others, just incorporate it in along with other considerations and other factors. We're going to spend a fair amount of time looking at this speed limit setting tool, which I think is a unique tool that can aid in selecting the appropriate speed, and then other expert systems as well. But first, this speed limit setting tool was designed to help practitioners in several ways: to assess and establish consistent speed limits, and then to combine engineering studies with context considerations. And don't just look at the engineering study in terms of it being a collection of speed records and that would produce a speed distribution, and then selecting a specific speed distribution to arrive at a speed limit or posted speed. And then it's intended to be objective, unbiased, and a consistent process. First, just as far as a review, let's look at the 85th percentile rule that is laid out for us in the METCD. The early research centered on rural roads. So that's one issue I think that some folks have with using the 85th in urban and suburban areas, is that the research was based really on rural roads. It does rely upon the driver's reasonableness and prudence. So that's why you have the 15% that we're not necessarily saying they're not reasonable and prudent, but they're going to be the most egregious, offenders, as far as you're always going to have people that are going to be driving too fast. You're always going to have a 15th percentile, no matter what the speed is. And typically those are going to be the drivers that are going to be going too fast, and those are the ones that should be ticketed. As far as another thing about the 85th is it's reactive, as far as it's really not set up to address future contexts and changes to the roadway that could be occurring overnight, so to speak. And that's something we talked about yesterday. Are speed limits, can they only be lagging indicators, or can they be leading type indicators? And should they be? Should you be allowed to look toward the future, just as with signal warrants, a lot of times it's based on projected traffic. Well, should speed limits be based on projected context and changes to the roadway? The study process does, and I think this is sometimes ignored, that in the METCD in 2B13, paragraph 16, it talks about other factors. And those other factors they're basically whatever you can come up with and derive to be important to the overall context of the study as far as setting speed limits. So how does the speed limit setting tool differ from the METCD? We're going to look at that in a little more detail. It is data-driven, it's research-based, it incorporates contemporary policies and guidance, and is transparent and consistent. That's one thing about maybe the 85th percentile rule, and then just the inclusion of other factors. Well, one agency may weigh in, pedestrian and bicycle activity, volume of, pedestrian crossings, things of that nature, while others may only look at, ADT, number of driveways, et cetera. So, different agencies can come up with different speed limits for the same roadway, theoretically. The speed limit setting tool strives for consistency in the decision process, and it does allow for the 50th percentile consideration on city streets and those to be within 5 miles per hour of the 50th percentile. And so there's a procedure for doing that. It's not that you can do it under any circumstance, but there are procedures to do that. So the speed limit setting tool is built around 4 key steps, and that is to determine your roadway type and context. Then you look at your speed distribution, and you look at the safety aspect in terms of crash records, et cetera, problems that are occurring along that section of roadway. And then from that, you arrive at a suggested speed limit for the particular roadway. So all this comes from the, as I said, the NCHRP report 966, and it uses the this roadway context and type, as I had discussed yesterday, in the for arriving at a target speed, similar to that. So you have rural areas, which would be just totally rural. Then you have rural towns. This would be like maybe towns of maybe less than 2,000 people. Could be still considered a rural town. So in that particular area, you would have maybe a different set of conditions that would determine a suggested speed. And then you would have suburban areas, urban, and then downtown urban cores. So those are your 5 areas. And from that, you determine your functional class, and that would be in this case, it would be the rural town, suburban, urban, and urban core would be your quote, your functional class. And you would choose that based on, your density, your land use, and then any setbacks along as far as, sidewalks, streets, parks, on-street parking, things of that nature. And then you go to your suggested target speed by roadway context and class. And we looked at this yesterday and then again this morning. So that's just the same table there that you would use to build that from. And then from that, you get your speed limit setting guides, which would, again, you have your different functional class, freeway down to local, and then you have your functional classes from the speed limit setting tool research that would provide you with the suggested categories. So for freeways, everything is pretty much across the board, no matter where it is, from rural to urban town, urban core rather, it's limited access. And then for these others, maybe in rural towns, this would be considered developed, and then urban core, it may, translate over to full access. So this kind of gives you a feel for where these different speed limit setting groups would come from. So the speed limit setting options, these are suggested from highest to lowest. And so for the one category is the 85th percentile rounded to the closest 5 mile per hour increment. That's classified or identified as C85. So closest to the 85th. The 85th percentile speed rounded down to the nearest 5 mile per hour increment. So that's RD rounded down 85. And then the 50th percentile speed rounded to the closest 5 mile per hour increment, or closest 50. And then for the 50th percentile rounded down would be the RD 50. So these are the different categories that you would fall into to help you determine what the suggested speed limit would be. So these are based upon different variables for speed limit setting group. That's the SLSG. And then the speed limit setting might be whenever that speed limit setting might trigger one of these particular groups to be used. And this all comes again from from tables 5 through 10 of this research report. So your inputs from your working through this are your roadway segment inputs. You have about 23 of those. Crash data, you have about 8. And speed data, you have about three of those. So let's just look at a example of how this might work. And then I'm going to show you a printout, if you will, of the speed limit setting tool. all of this information is available in the report, and the tool is available for download as well. It's just a spreadsheet. So let's say you're on a limited access facility and it's in a large city, and here's all your information. So you got a 6.5 mile segment length, you got 130,000 vehicles per day. All these are going to be inputs into the spreadsheet. You have 3 years of crash data. You got the number of lanes is 6, number of interchanges is 5, design speed is over 60, 60 or greater. And then you have a grade, you have outside shoulder width, inside shoulder width, maximum speed limit. This would be the statutory speed, current speed limit posting. And then you have your 80th and 50th percentile from your speed study. And there's no adverse alignment present. So with all these input variables, the suggested speed limit is computed as 70. The speed limit is identified as it's a rounded down, or RD85, because of the narrow 2-foot inside shoulder width. So this is essentially what it looks like when you're using the tool. And again, I know it's hard to see from this, but you can download the tool from the TRB website. So it gives you your your different input areas for your speed data, site characteristics, crash data, and then basically it gives you the suggested speed limit of 70. So that's one tool that's out there. I think it's got a lot of potential, and there may be already some agencies that are using that particular tool. But one to look now at some other expert systems that are in use. I do want to revisit the MUTCD because I know with the notice of proposed amendments that came out last December, and then comments I think were due by May, there was a lot of comments to and you can go in there and look at it yourself. There were a lot of comments to the docket on 2B on setting speed limits. There were some changes proposed in the MPA related to speed limit setting. And there were a lot of comments that were both for and against the changes. So it's going to be interesting to see how those come out. So that's pretty much all I can say on the MPA at this point. But the current, the 2009 edition, it does require an engineering study, and it has to be set in 5 miles per hour increments. So you can't have a speed of 82 miles per hour. It's not the good, the bad, and the ugly. It's the shall, the should, and the may. The should, or the guidance, is that the 85th percentile should be used, and it should be within 5 miles per hour of the 85th percentile. And then this is the part that I think a lot of times people overlook, is that it may include other factors. And these are just samples of other factors. It's not an inclusive or exclusive list. Road characteristics, roadside development, parking, pedestrian, et cetera. All of these can be other factors to be considered. So, meaning that even though you may get an 85th percentile speed of, say, 60 miles per hour, when you consider these other factors, crash experience or roadside characteristics, pedestrian activity, et cetera, bike lanes, number of conflicts, observations, things of that nature, they could change. You can change it from 60 to, you round it down, you round it up, you can move it up, move it down. That's dependent upon the engineer and the engineer's discretion and judgment based on those studies. So when you look at what different agencies are using, it's interesting to see that overwhelming majority of agencies are still posting speed limits based on the 85th percentile speed. Now, it doesn't mean that it's exclusively on the 85th percentile speed, but others are using things such as crash frequency statistics, surrounding land use, number of access points, functional class, et cetera. So, and these are all the other factors. So if you wanted to look at other factors or, outpace the use of the 85th percentile, when you sum them all up. So I thought that was interesting. That comes from AAA. The SAFE systems approach is based using that particular approach. It's based solely on a road safety platform. So SAFE system approach attempts to minimize injury to the road user, whether it's pedestrian, motor vehicle driver, occupants, etc. So speed limits are set according to the crash types that are likely to occur along that particular roadway. If it's a roadway where you don't have much chance of rear end crashes, then that's taken into consideration. If you don't have much chance of right angle crashes, that's taken into consideration. So all of these things will be taken into consideration in terms of like your potential crash types, which would go back to your conflicts that are present along that particular roadway or along that series of intersections that could impact the selective speed using the SAFE system approach. And it's also uses the impact forces. That's the calculation of the speed and angle, and then the kinetic energy that's likely to be dissipated from that type crash. This also considers the tolerance of the human body to withstand these forces. So again, it's looking at impact forces, but not only that, but the maybe you're in an area where there's a lot of senior citizens, and their tolerance to withstand forces are going to be less than what a 20-year-old may be able to withstand. So that could impact the choice of speed in certain parts of the country, certain suburban, urban areas of the country, or different towns or cities based on that fact alone. And then the different crash types and patterns for the different road types is also a consideration, and then survivability rates for different operating speeds. So we know that if you choose a 70 mile per hour operating speed, then the survivability rates from right angle crashes are going to be slim to none, versus if it's a merge diverge type crash at a operating speed of 70, then the survivability rate would naturally be higher. So all these things are taken into consideration to come up with these different speed limits. So these are just the road types, and then it provides you with the speed limit. So these are not all that, I guess, stark in contrast to, in comparison to what is typically would be used on these roadways, these road types, but it does provide, I guess, another tool in assessing appropriate speed limits. There's also a NACTO approach, which is a risk-based approach focused really on urban areas, because it's the National Association of City Traffic Officials. But it is a proposed risk-based system for setting speed limits, where you're looking at pedestrian bicycle activity, you're looking at location, is it a retail corridor, is it heavy sidewalk usage, bicycle paths or usage, shared use pathways. It's based on a conflict density type of analysis and the activity level analysis of this, that the street actually has. So, you can get more information on this particular risk-based approach by going to the NACTO website. And there's also US limits. So I'm sure some of you are familiar with the expert system approach, US limits. It is a decision rule-based expert system. It uses tree logic it kind of mimics the engineering judgment based on traffic engineering principles and experiences. It does consider all factors such as geometry, traffic, operation safety, ADT, et cetera. Considers road users and context factors. And it can be, it provides the 50th or 85th percentile speed. for usage as your speed limit. Some examples of the decision rules are for streets and highways through developed areas, the recommended speed is based on access density, average signal spacing, the amount of parking use and activity, and the amount of pedestrian or bicycle activity. For example, if the ped bike activity is high, or there is a lot of parking activity, or there's more than 60 access points per mile, which is quite a few, or more than 4 signals per mile, then the recommended speed is based on the roadway factors. It's the median speed rounded to the nearest 5 mile per hour multiple. And if that access density is between 40 and 60 driveways, and let's say the area is neither commercial or residential, then the recommended speed is 85th percentile speed rounded down. So this is just some of the logic tree that is used in the US Limits 2 tool. Now there is a update currently underway for the 2000, well, not exactly sure what year it's going to come out, but it will be the US Limits 3, which will, I think, be a little more robust than this existing decision tree rule. There have been some complaints about the US Limits 2 that it provides speed limits that are, or recommended speed limits that are too high, and it really doesn't give enough weight to these, to the other factors that are built into the decision rule logic. So we'll have to wait and see when US Limits 3 comes out, whether or not that's going to be, I think, satisfying some of the people who had complaints about the earlier one. Some additional information, this Project 1776 is guidance for setting of speed limits. That's a, this is available on the FHWA website. And then the Project 1779 is the safety effects of raising speed limits to 75 miles per hour or higher. That's specific to, you know, just certain roadways. And then there's information on the safe systems approach, setting safe speed limits on urban streets. And there's a user group and enhancements for the use of the safe systems. And there's also expert panel that's involved in that as well. I'll be providing at the end of the webinar today I'll be sharing a link to a resource page that will have a lot of these different websites and guides and different publications that you can access to get more information on a lot of the tools and resources I've discussed today. So one of the other tools is this one on reducing speed-related crashes that involve passenger injury. So this would be an injury-based type of tool that seeks to minimize injury. But the National Transportation Safety Board has weighed in on US Limits 2, and they're basically saying that, you know, it should be altered or changed, or I think that's may have had something to do with the timing of the US Limits 3 update. But the MUTCD in Section 2B13, it does require an expert system such as US Limits 2 to be used and remove the 85th percentile speed. So that's one of the recommendations of the NTSB, and then to also to revise it and incorporate the safe systems approach. So the National Transportation Safety Board is just, they're weighing in on the use of speed limits, how speed limits are set, I guess in large part due to the fact that where there is a catastrophic crash on any transportation network, then National Transportation Safety Board gets involved and conducts a review and study of the what led up to the crash, what the causes of the crash were, and then also the recommendations for, you know, improvement and this has been born out of that, their work over the years. Okay, what I'd like to ask Matt to do now, or Ayrton, to post, if you will, into the chat area, each link for question A, B, and C. And what I'd like for you to do is respond to these different questions. But because we have such a large group, if your birth month was January to April, then choose question A, please. If your birth month was May through August, then choose question B, please. And if your birth month was September through December, then choose question C, please. So if you would, just respond to one question using your birth month to determine which link you click on. So it's kind of a new twist on polls, but we're trying to expedite this, make sure we can cover most of this material today. So if you would just do that, and I'll give you time to respond to that, and then I will jump in here and we'll look at your responses. Checking here, make sure we got participation in all these different polls. All right, looks like we got responses coming in on all of them. That's good. Got some folks that are still awake out there. All right, let's go ahead and look at some of these. We're getting in some responses. So the first question dealt with, of the various methods for establishing speed limits, is there a best practice or preferred method? So that's kind of an open-ended question. Again, depending on, kind of which aspect you're coming at this from, based on your, current job duties, I think would say a lot. All right, so we got certainly people that are saying the 85th percentile method. And then, of course, METC standards and speed studies, that would include, of course, other factors and specifically US limits. Not sure what that is. The METCD 85th percentile method, 85th rounded down. No is, I guess, a valid response. There's not a best practice or preferred method. Got a yes, there is a best practice or preferred method. I think, this is certainly going to vary. And simple answer was, yeah, yes or no. But using these different systems, whether it's safe systems, we got one in here for that. It's going to, and we have evaluating operating speeds, various factors using an expert system, 85th percentile, taking into account all variables to determine the speed. And we got the SLS method, safe system, safe system. All right, typically 85th, we're looking to incorporate safe speeds. Okay. Okay, so I think this is an interesting mix. It certainly addresses the standard use of the 85th percentile, but then there are some that are saying, yeah, there is a best practice or preferred method, but it would include looking at these other tools to maybe weigh against the to either support, confirm, or to have you question the value that you came up with using the 85th percentile method when you consider other factors. So it is I think what this says too is that it truly should be an engineering study and not just a, let's go take a field measurement of the 85th percentile speed and do a speed study. An engineering study is different from a speed study. A speed study can be part of an engineering study, but an engineering study implies a comprehensive approach to solving a problem or arriving at a solution or a design. So I think that's something I think we can glean from in this particular, with that particular question. So let's look at the next question. The next question was, is it a good decision to use more than one method? And then we got the why or why not. So we've got a lot of yeses. We got a few no's in there, but I think the overwhelming majority of people say, yes, it's a good method, a good decision to use more than one method. Why or why not? So maybe this will tell us a little more. It helps, you know, with the best judgment, better picture of the roadway as a whole. Use well, it froze up there. All right, yeah. All right, so it helps to validate your engineering decisions if you're using more than one method. Multiple data sources is good. I think when you're using a lot of different inputs for a roadway section, then that can help you to determine that what the appropriate speed is. 85th percentile speed does not take a lot of the input data from these other tools. It doesn't even take that into consideration. So I think that's certainly a value in using these other tools in your engineering study, in that it does require a lot of additional data. Check, you know, multiple methods, good. Double check results, find solutions, take into account various factors. Yeah, all of these are great answers. Yeah, great, really great answers. A lot of good insight there. So thank you for responding to that. And then the last question for the September, October, November babies. We've got, when results differ between methods, what is a path forward? So these guys, they really had to carry the brunt of this, these questions. I think maybe 5A and 5B got off a little easy. So let's see what 5C did. When results differ, what is a path forward? All right, use the most conservative results, engineering judgment. Refer to administration, that's a good one. Look at more methods, look at history, look at consistency across nearby roads. That's good. That's taken more than one roadway into consideration. I think that has good merit. Engineering study, engineering judgment, roadway context and type, fall back on that. Lean on the 85th percentile, safe systems. Engineering methods, use design, speed, set speed limit a minimum of 5 miles per hour or lower. Not sure what that is exactly, but go with a lower value derived because the areas around the roadway may develop. All right, that's kind of looking at a downward trend versus an upward trend. And then context sensitivity. Go with the slower speed. Use more conservative result, conservative approach. So conservative approach, I guess, would imply that you're using a lower speed. Consider the corridor and the SLS tool used in engineering study. All right, those are interesting. We're gonna, I guess if we have time, hopefully toward the end, we'll be talking about artificially low limits, what can result from posting speed limits too low. Are there negatives from doing that, which was, I think, suggested here in a couple places. But it looks like the overwhelming response here is just not only to use engineering studies and judgment, but to also err on the side of being conservative with your speed limits and your selection of speeds. So, all right, good. Any questions for me in the chat area at this time? Whoops, somebody answered the wrong question. You need to check and see when your birthday is. So you may not have any goodies this year or presents. So. All right. All right, what we're going to do now, and if you have a question, throw it in the chat pod. I'll try to jump to that before we jump into this next module, if there are some questions. But now we're going to turn our focus for a few minutes. Probably just do a little introduction here, then we'll take a short break. So we'll have a short break coming up here in just a few minutes. So again, if you have questions, feel free to throw those in there. Okay, so I do see let's see, is this a question or a statement? Answer on review. Choose the speed. All right. Is there an application where allowing drivers to choose the speed limit via determination using percentiles would align with promoting safety objectives? I guess I'm not following your question there, Daniel, and related to via determination using percentiles. So if you want to unmute and come on, you can, or if you want to just clarify that, help me out there, that'd be good.
Yeah, I mean, basically when we talk about using 85th percentile, we're letting the motorists, the drivers, decide what the speed limit is based on how they use the road. So what I'm asking is, you know, what's the alignment between letting a user of the road determine how fast they want to go? Is there ever a situation where that would actually help with safety objectives that we're trying to decrease crashes on the road?
Well, it's the 85th percentile, I think, is based on the research, it indicates the level at which there is I guess, the best measure of safety and comfort for the driver. If you get below the 85th percentile, I mean, if you get too far below, whatever that is, if you get too far below the 85th percentile, it can have, you know, negative type of consequences. If you get too high above the 85th percentile speed, then of course you would have some negative consequences from that too. But 85th has been shown to set the bar, if you will, for what a reasonably safe speed, maximum speed is. And I think a lot of issues come into the setting of the speed limit. It's not so much the speed limit that determines the safety of the roadway. It's other things such as, you know, the pace speed, you know, the volume, you know, the headway, things of that nature are all, I guess, part of the safety equation for a particular roadway. But as far as the concept, I guess you're referring to or speaking of, as far as letting the drivers determine what that speed would be, even if it's in excess of the 85th percentile, I'm not really sure how that would play out. I do know, again, based on my observation, that the speed limit, it's interesting that because when you think about it, whether or not the 85th percentile is the best predictor of safe speed, if speeds have gone up, then I guess the question is what has caused those speeds to go up say on a stretch of roadway, interstate freeway, where maybe the 85th percentile speed has gone up, excuse me, let's just say 5 or 10 miles per hour. It's gone up. Well, what's caused that speed to go up? Evidently, drivers feel safe. Some measure of drivers are feeling safer going higher than the previous 85th percentile speed. So what has caused that? Is it caused by lack of enforcement? The perception that a lack of enforcement then allows me to, whereas I was more hesitant to, go over the speed limit out of fear of being, ticketed. Now that maybe there's less enforcement on the roadway, then I'm much less, inhibited to, to drive at a faster speed. So I'm probably rambling here, and I probably haven't addressed your question either. But I don't know that would. I'm really not sure how that would promote the safety objectives.
That's great. Thank you.
Okay, when designing a new road, the design speed determines the minimum road geometry. Should the geometry be designed not to encourage users to exceed the design speed? If so, how should the maximum speed used be determined? Well, with roadway design, you have different speeds. You have the design speed. You have the safe stopping sight distance. You have speed. Minimum, radial curves, et cetera, based on the speed. So there are several factors that come into play based on your roadway, your alignment, that can may impact your design speed. It may not. You may have a curve on a particular road with a design speed where the safe speed in the curve is maybe 10 miles per hour less than the design speed of the roadway. So there are times when you need warning signs and things of that nature because there are limitations to being able to achieve that speed throughout the entire length of the project. So I think there are times when the design speed could be higher, and it wouldn't necessarily translate into a higher speed, operating speed. So maybe going back to the example, the fact that a curb and gutter, back to the Wilson Dam project that we went over earlier, the fact that there was a curb and gutter was desirable on the project from the design perspective. Having the curb and gutter, I don't think necessarily translates into that being a big factor in choice of operating speed of drivers. Whether or not there's now maybe if you're in the rightmost lane or something of that nature, if there's a curb and gutter that's right at the edge of the travelway, it could impact that particular. But if there's a paved shoulder on the left side, or a shoulder and a curb and gutter, that won't necessarily impact the speed of the driver, the operating speed. So I think what I'm trying to say is that the design speed will not necessarily impact the chosen speed for the driver. It may have a small impact. Different features of the design are going to have maybe an impact greater than others, certainly. But I don't know that the design speed and all of the features, geometric features, roadway features that are included in the project based on a design speed are going to impact the operating speed. I think we've already talked about the difficulty in making a comparison or a relationship between the design speed and the operating speed. It's almost like the design speed. I don't really think of it as a speed. It's really I mean, you could call it something else and it would have the same effect. It would basically it's a file cabinet drawer of features, geometric features, and roadside features, and things that you would want to include on a project, as opposed to it being a really a definable speed. Okay. All right, let's do this. Let's jump into this, and then we're going to take about a 2-minute break here pretty quick. All right, so what I want to do, I want to cover some countermeasures, but I want to group them into three primary categories, because I said yesterday that this makes up a large percentage of the problems we have related to crashes and speeding, is if we can control these different groups and well, the different groups, and as far as and roadway features and types of first harmful events. It's kind of 3 different areas there, but again, they make up a large part of our crash problem. So we're going to talk about a guide to countermeasures based on a focus area. So there's a lot of ways to counteract speeding, and there are multiple approaches. We've been talking a lot about the engineering approach, and we're going to stay on that with traffic control devices, streets and designs, road designs, traffic calming gateway. Then we're going to talk a little bit toward the end of the time today about enforcement and education. So let's start with pedestrians and cyclists. If you look at this, speed has a lot to do with the fatal crashes, and we all know this. 40 miles per hour, you have many more, you have a greater chance of death if you're a pedestrian or you're on a bike. If you're struck by a vehicle traveling 40 miles per hour. You're still likely to be injured at 20 miles per hour, but again, the deaths are about 5%. So certainly advantage there to slower speeds for bicyclists and pedestrians. One of the problems with safety issues related to speeding is that for pedestrian and bicyclists, it's hard to accurately measure safety issues. For one thing, pedestrians, in most states can cross the roadway anywhere at any time. With the exception of most states have a law that pertains to crossing between 2 signalized intersections. Mid-block is against the law. But in most places, you can cross pretty much anywhere at any time as a pedestrian. And so when you consider the rules of the road for motor vehicles, most state laws are heavily weighted toward motor vehicle traffic laws and rules of the road, whereas for the pedestrian, there are almost 0 rules of the road. So it's almost like herding cats, maybe. It's difficult, because if you can imagine if cars and motor vehicles were allowed to go anywhere at any time along the roadway, they could create their own driveways by pulling off the road and, across sidewalks where there's, maybe a curb and gutter or whatever, and just could drive and exit the roadway anywhere they wanted to, make a turn at any time they wanted to, mid-block or within an intersection. It would be total chaos. So whereas we need to address pedestrian and bicyclist safety issues, I think we also need to be looking at, as this pedestrian bicycle traffic increases, the need for stricter rules for pedestrians and bicyclists. And I think that would certainly need to be a part of our overall safety work that we're doing. 60% of pedestrian and bicyclists are speed-related fatalities. They're occurring between 6 p.m. and 5 a.m. So that's pretty much most times of the year, that's in darkness. And that's certainly an overrepresentation. Here's the case in point. Most of these crashes are not occurring at an intersection. They're mid-block locations, or they're sidewalk related between two intersections, or they're someone crossing a road or waiting in a median and then trying to cross the road, but they're happening at a non-intersection location, which is unregulated. Basically, that's unregulated for the pedestrian. So what I want to do, I want to play this video, and then we're going to take a break. This video is just a few minutes. So let's take a look at this, and then we'll go to break.
Pedestrians can face many dangers when crossing the road. How am I going to cross this road safely? Did you know one of the most important steps you can take to keep pedestrians safe is manage the speed of vehicles at pedestrian crossings? Consider this. If this car moves through the crossing at 42 miles per hour, there is a 50% chance that I will die if struck. As speed goes down, however, the chances of a fatal crash drop dramatically. Another issue is sight distance. As a car goes faster, the driver has less time to detect me trying to cross. If a car approaches the crossing at 45 miles per hour and the driver notices me here, this is how long it will take the car to stop. Uh-oh. At 25 miles per hour, the driver has more time to react. Many urban cities are adopting the safe system approach and have changed their posted speed limits to 20 or 25 miles per hour. Driving faster near crossings also reduces the driver's cone of vision. As cars go faster, drivers see less. Slowing down opens the cone and helps drivers see pedestrians. So how can we slow cars down prior to mid-block pedestrian crossings and save lives? Glad you asked. There are many effective countermeasures. For instance, curb extensions bring the sidewalk or curb line into the parking lane, visually narrowing the roadway and improving sight distance between drivers and pedestrians. Pedestrian refuge islands also visually narrow the roadway while allowing pedestrians to safely wait for a gap in traffic, focusing on one direction at a time. For two-lane crossings, raised crosswalks are a great option. They improve visibility by raising the pedestrian to a higher level and provide a raised platform to slow cars approaching the crosswalk. Road diets can reduce the number of through lanes and the lane width, which encourages drivers to slow down. Road diets also reduce the distance people have to cross and create space for other safety countermeasures such as refuge islands and curb extensions. Slower vehicle speeds at crossings save pedestrian lives. Contact FHWA for more information on these and other life-saving countermeasures.
Okay, let's take a break. I've got 10:23 my time, 11:23 your time. Let's reconvene in about 12 minutes or 11:35. We'll start back up at 11:35. Okay, well, I hope everyone's back from break now. We're going to, Joe, go ahead and jump right back into this and continue on. So we left off looking at some countermeasures and treatments that we can do for enhancing pedestrian and bicyclist safety. All right, just trying to make sure I got all my screens up and screens down. All right, so some of the potential countermeasures, some were pointed out in the video, and some of these may be repeats, but installing medians near intersections, clearly marked crosswalks, rectangular rapid flashing beacons, high intensity activated crosswalk beacons or hawks or pedestrian hybrid beacons, pretty much all the same thing there. Traffic calming measures such as humps, bulb outs, street trees, on-street parking, road dots, lighting, and in-roadway lights are some of the ones that you can do. So these are just, we're going to just quickly run through these, not spend a lot of time on them. There is a lot of information about these different treatments on the FHWA website, Office of Safety website, either at intersections or looking at pedestrian safety. Lane narrowing. This has been shown to reduce crashes. There are some research that shows that you could have an increase in crashes depending on, you know, the type of roadway where you're doing this lane narrowing. Typically, this would be more appropriate for, you know, your local roads, collectors, and things like that, in urban areas and suburban areas. You can do this with either striping, transverse markings on the center line, or you can do it with actual, you know, narrowing of the pavement width itself. This is an interesting treatment I saw on the right. And on Virginia Street in Reno, Nevada, we were doing a road safety audit out there earlier this year, actually doing a virtual road safety audit workshop. And we use this particular section of roadway for a road safety audit, mini RSA, if you will. And this these transverse markings with lane lines on each side of the transverse markings on the approach to this pedestrian crosswalk. This is a trail, comes in from the right, and up to the left there is a softball field, and this trail continues on up the road here, and then continues on its course. I'm not sure exactly where it goes, but anyway, there is a trailhead up here at this softball complex. So it does have a fair amount of pedestrian traffic that crosses the roadway here. But this, again, an interesting treatment. It's kind of a perceptual thing. I think maybe liked it better or done more to it, I think, on this upstream end, and maybe taper those lines out instead of using the 45-degree markings there on the tip of it. But again, lane narrowing is can reduce speeds, not by a great amount, but as we saw in the video, can have tremendous impact. Based on the study in I think it was 3 different states, North Carolina, Virginia, maybe Pennsylvania, saw an average of 4.5 miles per hour reduction in speed just from the lane narrowing. And then as far as crash rate, there was a 31% reduction in crashes based on those sites. So it was actually Pennsylvania, Kentucky, Missouri, and Florida. And then clearly marking your crosswalks, using things such as continental pairs, which are more, captures the eye of both the pedestrian and the motorist on approaching these crosswalks, as opposed to just transverse markings on showing the border outline of the crosswalk. So again, just more conspicuous, better recognition of these upstream by the motorists to, so they can watch for pedestrians. If they just see the borders of the transverse markings, and they're not, the crosswalk just does not stand out as well. And then rectangular rapid flashing beacons. These are very popular since the interim approval, and then the METCD team pulled the interim approval away, but now it's back. So these are likely to be in the next edition of the METCD. One thing about these, though, that some people do not take into consideration, or at least from my observation of a number of these things across the country, these LEDs, if you look at this picture on the right, are fairly small. There are no stipulations in the interim approval that says that these cannot be increased. There's a minimum size, but there's nothing about a maximum size. So if you think about these in terms of the square inches of these LEDs compared to a 12-inch signal head, these are almost non-existent. So particularly in a case like the picture over on the left, I would say these need to be increased for better recognition. These, just a standard size of an LED for RFB mounted overhead is really inadequate to capture the motorist's attention. So in areas too where you have a lot of urban clutter going on, whether it's other signs, things that are competing for the driver's attention, I would say consider increasing the size of those LEDs, either on shoulder-mounted, pedestal-mounted installations. And then hawks or PHBs are another way to slow speed along corridors too, where you're providing for the safe pedestrian crossings. And then there's vehicle driver activated signs, driver feedback signs. These can be permanent or targeted use, short term. They can be portable, on trailers or things of that nature. But these can be effective where you have where they're just on, or they just illuminate whenever there's someone in excess of the programmed speed. So like if the speed limit is 20 miles per hour, then when someone is over the limit, or maybe 5 miles per hour over the limit, then the sign would only be activated at that time. Other traffic calming measures, these hard line type edge line type dividers are another. The bulb outs we talked about, and then the speed tables are shown there. Road dots are good at perceptually narrowing the footprint of the roadway. They bring all users in tighter, where the motorist is more likely to actually see the pedestrian due to that cone of vision and the speed of travel. It does introduce roadside activity, which is a component of a driver choosing a speed. If you're in an area where there are schools and children along the sidewalk, you're more likely to adjust your speed than if it's just a simple shoulder and there's no activity on the shoulder. And then most road dots provide for pedestrian crossing. Lighting is key. We did see earlier that 60% of the fatalities of pedestrian and bicyclists are occurring at between those hours of 6 p.m. and 5 a.m. So lighting is critical. I would also mention here that the type of lighting too, there's been some studies that have shown that lighting of the offset of the pedestrian crosswalk is better because it actually shines light on the pedestrian himself or herself, and as opposed to just creating a shadow with it being directly overhead. So anytime you can illuminate the pedestrian, it's better than illuminating the crosswalk. Not that you're going to do both, but you can do both depending upon the position of the lighting. It's typically, a little bit upstream and a little bit downstream of the crossing to get the most light on the pedestrian as opposed to just being directly overhead. I've got a video here I want to play, but this video, I just have to kind of do a disclaimer because there is some graphic images in it and footage of pedestrians that are struck by motor vehicles. It is a foreign documentary of the effects of speed on ped vehicle-related crashes. The depictions show no blood or injuries close up or anything like that, but the video is shown for its value of understanding the vulnerability of pedestrians using the right-of-way and the impact adjustments in speed can have on the severity of such crashes and whether or not a crash occurs. So if you care to skip the video for these reasons, then please do so. The video is about 3 minutes long. So if you do want to not, if you want to pass on it, I certainly understand. And I would just ask you to, step away at this time. After I read the next statement, I'm going to start the video, and those scenes don't occur until about midway through the video. So again, just exit at this time and we'll watch this video. I do want to say that the action is fast in this particular video. Things move rather quickly, and the closed captioning is in English at the bottom of the screen. And so just keep an eye out for that. So I'll start the video at this time.
สัก40ก็พอแล้วค่ะ
60ประมาณนี้ครับ
40-50มา
ถ้าเป็นบางคนเร่งรีบก็อยู่หน้ามัน60-80
นั่งให้ถนัดได้เลยครับพี่คุณเอกครับเดี๋ยววันนี้เรามาร่วมทดสอบรถด้วยกันแล้วกันเนาะลองอีกทีครับกระทืบเบรกเต็มแรงดีมากนะครับไปได้เลยครับอีกนิดนึงปลาย50รักษา50ไว้ครับ50ครับ50ครับชนสิครับใช่ครับผมหลายมากเลยเมื่อเกิดเหตุเป็นอะไรลองดูป้ายครับ30ไปเรื่อยความเร็วแบบนี้ช้าไหมช้าครับผมช้าเห็นน้องข้ามถนนอย่างปลอดภัยไหมนี่คือหนึ่งเหตุผลในการขับรถด้วยความเร็วที่เหมาะสมในทางแคบมันช้าแต่ถ้ามีเรื่องขึ้นมาเราเซฟชีวิตคนได้1 คน
Okay, powerful video. Some issues about pedestrians and also about choosing some different countermeasures is that it's hard to identify pedestrian safety because of both data quality and quantity. As far as pedestrian counts and things of that nature, they're just hard to a lot of times to come by. So it is difficult. Can be difficult to identify problems and where those problems are occurring. It helps to have a data management plan or an improvement plan, how you're going to maintain the data, and then also reviewing pedestrian facilities periodically, have some frequency of doing that, and also maintaining inventories of mid-block crossings, installations of RFBs, pedestrian hybrid beacons, etc. 40% of speed-related fatal crashes or pedestrian bicycle crashes took place between 6 p.m. and midnight. And the next highest was from 5 a.m. with almost 20%. So what can you do? We talked about lighting. RFBs are another great one because they are pedestrian actuated, and then in roadway warning lights as well whenever there's so aside from just the pedestrian activated, you can have motion type detection as well. So pedestrians are not going to push the button for the RFB, then you can use motion type of detection. Majority of speed-related fatal crashes do not take place in intersections. What can you do? Well, that's a lot of the difficulty is that category alone. Median islands or refuge islands, pedestrian hybrid beacons can be a help. Barriers that can channel and funnel pedestrians to a preferred location, such as a mid-block crossing, as opposed to them crossing between someplace other than mid-block crossing at a mid-block location. So anytime we can provide information to the pedestrians, such as, you know, cross on the other side or cross on this side of the street, et cetera, or there's a crossing 200 feet, you know, down the road, et cetera, you know, just communication. I think that's part of that outreach and education is important as well. What are some other additional countermeasures or context-sensitive design, and then road dots for including all pedestrians and all users? Look now at intersections. Intersections account for about 20% of the speeding-related fatalities, but there's a big chunk or non-intersection related. That's the blue chunk. So we're looking now at just this green and this red portion, which are both signalized and unsignalized locations. So what are some potential countermeasures to reduce speed? Well, signal operation improvements could be one, improve the visibility of intersections, traffic calming, indirect left turns, using high friction surface treatments, and then facilitating left turns at median openings. Just a review of signal timings can sometimes help, making sure you have adequate red and clearance intervals so motorists are not caught off guard and they're having to speed up to try to make it through the light. We don't want motorists caught in the dilemma zone when they tend to make more, more errors in judgment. We want to try to eliminate that so that it will be clear whether or not they should stop or continue. And then coordination of signals can be appropriate, and then using advanced warning signs, making the visibility of intersections more apparent, conspicuous, making your signalized intersections, your signals themselves more conspicuous, using reflectorized backplates, mounting on mast arms versus span wire can also be a additional improvement as far as the conspicuity of traffic signals. Reducing conflicts, potential conflicts such as left turn movements, crossing conflicts, and things of that nature can be done either through changing phasing or by using alternative intersections, indirect left turn intersections, such as median U-turns, restricted crossing U-turns, J-turns. Any number of things can be done to reduce those conflicts, not just changing phasing. And then assessing signal progression impact, what impact is being made by having signal progression. Is there a negative or a disbenefit in using signal progression? Has there been an increase in crashes with signal progression, or has there been a decrease in speed with timing of signals and adjusting those bandwidths of your different cycles and different intersections? Doing that system-wide too. For unsignalized intersections, you can improve visibility of signals, of those signs, excuse me. And traffic calming measures can be of help too, whether it's chicanes or raised median islands, mid-block crossings. A lot of these things can help as well. And then indirect left turn intersections can not only reduce number of crashes, but can reduce speeds through these types of intersections as well. Special areas of focus would be arterials, motorcyclist crashes, right angle crashes in rural areas, and resistance to roundabouts is another focus area. Roundabouts have certainly been proven over the years to be a tremendous safety benefit and speed reduction as well through intersections. A lot of the problem is on arterial roadways where these speeding related crashes are occurring. And again, a lot of these countermeasures are appropriate for those particular roadways. And motorcyclists have a high risk of being involved in speed related crashes, targeting education campaigns, making the conspicuity of motorcyclists better, and then emergency response training. So a lot of this gets into some of the speed management type programs as well, and may address some of your strategic highway safety goals and plans. Without question, the highest number of speed-related crashes, fatal crashes, involve these angle crashes at intersections. So promoting things like roundabouts and even mini roundabouts, having U-turn based intersection designs, and then using automated red light enforcement. Speed-related crashes are really a rural and local problem overall. Not to say that there aren't problems in urban areas, there are, but the speed-related fatal crashes are particularly a problem in those rural areas. So you can do things such as visibility of intersections, enhancing that, providing rumble strips, high friction surface treatments to improve braking distance, and detection control systems, rural ITS solutions such as intersection control warning devices that would alert motorists of vehicles in the intersection or approaching the intersection. Using a transverse and optical speed bars, so drivers get the perception or that they're traveling faster than they actually are, and then using U-turn based intersection designs, and then providing left and right turn lanes also to separate faster traffic from slowing traffic. So there's still a lot of, I think, public perception about roundabouts, mini roundabouts, that is not conducive to promoting roundabouts and to constructing roundabouts. So there should be things such as education and outreach about these, and also show life cycle costs and savings benefits and the success other agencies have had from roundabouts. I want to quickly go through lane departure. Lane departure is any type of crash which occurs when a vehicle either crossing the edge line or center line or otherwise leaving the travel way. So kind of defined that yesterday and gave examples of that. Not surprising, 40% of fatal road departure crashes are speeding related. A number of these crashes, a great majority of these crashes are occurring at horizontal curves, even though they represent a very low portion of the overall roadway miles. So the goal is to keep vehicles on the road and minimize the consequences of leaving the road and reducing those head-on or serious crashes. So some of the information that is helpful in terms of diagnosing the problem would be determining your crash types, where you have speed limits that are, whether or not those speed limits are maybe excessive in some of these areas where they should be reduced, your horizontal curve alignment in terms of warning signs and advisory speeds, and then what are the driver characteristics, what time of day are they happening, and what are the vehicle types, and then of course roadway geometry as well. So vast majority of these crash types, when they're run off the road or lane departure type crashes, they tend to be, of course, single vehicle type crashes, not surprising. The speed limit surprisingly, for these roadway departure crashes, it's a lot of times it's not the 55 and older group, it's the 40 to 45 mile per hour range and the 30 to 35 mile per hour range makes up a sizable portion, at least a third of the overall crashes, actually more. So some of the countermeasures include advanced warning signs, flashing beacons, speed reduction markings, enhanced signing, rumble strips, ITS type signing using safety edge, pavement markings, including transverse lines and decreasing spacing, lane narrowing, and then high friction surface treatment. Advanced warning signs are one of the keys to combating roadway departure crashes because they do oftentimes happen on horizontal curves or turns. Using flashing beacons and special chevrons are all, LED embedded signs can be advantages where you have problems on curves. A lot of problems on curves, not that you put on every curve, but based on those recommendations that are in part 2C of the manual related to the change in approach speed, the difference between the approach speed and the advisory speed of the curve. If that's pretty significant, then you'd want to probably use more advanced treatments than those described in MUTCD. Some agencies have experience with these arrows and things. They are experimental. I'm not necessarily a big advocate of that. I think it's kind of it's conveying dual meaning for both turns and curves, turn lanes and curves. Enhanced signing through curves. Dynamic signs that are only illuminated or flashing whenever the speed is, you're in excess of the speed that's programmed into the controller. And then rumble strips along center lines and edge lines, dealing with pavement drop-offs to combat safety edge, using the safety edge to combat these types of drop-offs that can occur from vertical faces. And then special pavement markings. These are the optical bars that can give the driver the impression they're actually traveling faster as they approach the curve, so helping them to slow down. And then some others are lane narrowing, transverse patterns of markings, wider edge lines and center lines, and then using more restrictive markings. On the approach to crosswalks and things of this nature for pedestrians, and even for lane departure, I wanted to show using this concept of increasing the degree of control. You can see there's a broken line used to separate lanes traffic moving in the same direction. So basically you have this broken line, which is a very permissive type of lane marking. If you use a double white line on the approach to a crossing, then you're basically prohibited from crossing that double white line. You can be ticketed for crossing or trying to change lanes, where you may be focused on finding a gap and selecting a speed. You may not be focused on the pedestrian. So you want to make sure you're doing things to promote traffic calming, if you will, on the approach to crosswalks. So you don't even have to use a double white line. You can use a wide single line, and as opposed to just a broken line, to enhance the degree of control, provide more traffic control for the motorists and the safety of all users. And then high friction surface treatments in curves can also minimize the effects of speeding in curves, because motorists don't realize they're actually on a more resistant pavement, and will allow them to brake at a shorter distance. So this can be won't necessarily decrease the speed, but it will provide accident reduction benefits. 85% of vehicles involved in speeding related roadway departure crashes were traveling on local, collector, or arterial roadways. So that's a pretty big group. I think that's over, 80% of the entire picture, with local and collectors being about a third, and arterials being about, I think, another, probably a little bit more than a third. So using appropriate speed limits on these roadways, speed limit reviews and data analysis where you're having these types of problems related to lane departure, roadway departure, is good to have that data available. This tends to be males, particularly in drivers age 15 to 20. We know these are part of the larger group in terms of fatal and serious injury crashes. So what are some specific countermeasures? Well-targeted education programs, working with other partners and stakeholders, and then using high visibility enforcement where you're doing targeted periodic enforcement along certain roadways. Other countermeasures for curves would be ITS signing, dynamic signing, high friction surface treatment, safety edge, pavement markings, rumble strips. Even standard curve signing has a crash modification factor associated with that. And then enhancing the signing. So wherever you have known problems or crash rates that exceed the average, then should be using some type of enhanced signing, whether that's fluorescent yellow sheeting or some type of marking or reflectorized sheeting on the poles themselves or posts. Rollover and overturn crashes present a problem. Crashing into trees are also related in about 75% of all road departure crashes. So having good data on where your different fixed objects are in proximity to the roadway, keeping vehicles on the road is one of the first signs or the first stages of strategies. And then reducing the potential for crash severity is the next line of defense. So we can't keep all vehicles on the road, but if they do leave the road, we want to make sure we're providing as many safeguards as possible. So things such as looking at clear zone, shoulder widening, and things of that nature, and safety edge. So that's a brief look at some of the countermeasures. It's not an exhaustive list of countermeasures for all roadways, but certainly these are some of the bigger ones. A lot of other countermeasures really deal with enforcement side of things and the education side of things. So I wanted to make sure I had saved a little time for that. It's not a lot of information. I think it's about 15 or 20 slides. So I think I may have time to get through that. I'm going to probably do it in a little bit of hurried fashion. So I want to make sure we have a little time at the end too. So I'm looking here quickly at some of the questions in the chat pod. And let's see. All right, is there any data showing the difference in effectiveness between the sign border lights and RFBs? I don't know of a comparison study. There was a study that came out, I think it was actually a Canadian study that looked at the most effective types of lights with warning signs. And the most effective was the bouncing ball or 8 or 12-inch signal heads with a warning sign of a symbol. Second was, I think, the use of the LEDs in the background of a sign in symbols. And the one caution, though, is not to use the LEDs within the background of a warning sign if it's a legend sign, because the problem sometimes, even with dimming, can be that the lights may be too bright at night for the motors to actually comprehend read and comprehend the message on the sign if it's a legend. But no direct comparison, I don't think, between RFBs and. You can certainly use a pedestrian warning sign with a flashing beacon. It doesn't have to be an RFB. So that's certainly an option. It's always been around. Bicycles or pedestrians that are on narrow roads where the right of way is between 5 feet have to improve these types of accidents. I'm assuming that's where you have 3 to 5 feet, maybe behind the travel way, where there's really not adequate room for a sidewalk. Maybe just some, even in rural areas or in suburban areas where you have pedestrians that want to connect from, one traffic generator to another, even casual walkers will walk up to a mile sometimes. So there could be benefit in providing just a paved shoulder for pedestrians to walk on, as opposed to being, off the road, well, there could be off the road, we don't pave shoulder, but off of the, onto the, that 3 to 5 foot section. If it's an improved walkway, even if it's a all-weather shoulder, that can be better than just walking on the shoulder itself, with just because it places the pedestrian within the roadway. And then signing, of course, too, shared lane use, things of that nature, sharrows, and can also be of some help. But that's challenging where you don't have much room. But pedestrians can use shoulders if there can't be a sidewalk that's provided, even though it's a narrow shoulder. Good question about level of service and maybe the detriment that would come from, I guess, sacrificing level of service by transferring some of that time to vehicles and PEDs. Some of that can be, I think, answered by looking at the fact that a lot of times the number of lanes, so to speak, may not. Whenever there's widening, that's a long. I don't know if I want to get into that or not. That's a long explanation to try to answer that question. Let me take a pause on that one. Maybe I can come back to that at the end or toward the end. That's a great question from Daniel about the effects of the countermeasures on speed. I think there needs to be more study in that regard related to these countermeasures, because if severity of crashes has so much to do with speed, then speed ought to be a component of should be some type of measure that would be associated with a crash modification factor. I think would be a great addition to the whole safety journey that we're on. But I'm not aware of any right now. I guess to answer your question. I think the answer to the 2-lane rural road question about bicycles, I don't know of any that would preclude you from doing that, having a sharing the road in that case at all. Particularly if they're off road, then they need to get on the road on part of the travel way. Then we just need to provide upstream notice of that for sure. Okay, we have just about 15 minutes left. And so what I want to do quickly is run through, and it will be quick, but we don't have a lot of slides in this area. So, okay. So I'd like to go through this, and then maybe we'll have time for another question or two. So a big part of the puzzle we haven't talked about yet, and I know it's one that's outside of most of our areas of work. And even though it may be part of our area of work, a lot of times it's hard to find time to make these connections that are so important in terms of the overall improvement we're trying to make with regard to speed and having reasonable and prudent speeds. Well, I just want to talk briefly about those things and look at some things that can be done. So as far as enforcement, we should be working with our partners to have some type of comprehensive enforcement activities that it can complement a speed management program, but it includes all other stakeholders, whether it's public, private, judiciary, enforcement, and engineering. And these activities should be data-driven, of course, and they should be sustained and highly visible. I think the sustained is big part of the problem. It's we can have special emphasis and targeted campaigns for work zones and then on Memorial Day and special occasions, but it's hard to sustain that intensity over time due to a number of reasons, whether it's budget, just other resources, or whatever. As far as enforcement, pace speed is important in terms of targeting egregious drivers. Sometimes pace speed can near or be over the speed limit, as is true for a lot of our arterials today. It does require calibration of the equipment as defined by state agencies and department. This is all, again, goes back to public safety or municipal police. There are different ways to have speed enforcement, whether it's use of a motorcycle patrol, even aircraft. You see a lot of signs out there for aircraft enforcement. I'm not sure how much of that's going on right now, but there's automated enforcement too, whether it's mobile or fixed. So some states are using some type of automated enforcement. I think out in Arizona, there's some out there. Types of signs to enforce it. These can be either just general SHS signs. They can be fixed in advance, or they can be temporary advance. It's just for target enforcement, short-term type of enforcement. As far as the judiciary is concerned, what their role is that by and large, judges don't have any bias or preconceived positions, and they can't dictate to the states how to set the speed limits or to enforcement to the police how to issue citations. So they don't get involved in, well, was he 5 miles over the speed limit or 10 miles over the speed limit? But in all cases, they have to apply the facts of each case fairly and impartially. So each state has a form of canon of ethics for their judges, and they can't compromise that. Convictions, judges have to look at the absolute speed. Was there reasonable and prudent speeds? Was there a failure to reduce? Was it reckless type of operation, or was it too slow for conditions, or was there some type of negligence involved? If it's reckless driving or something of that nature, it's certainly going to be taken into consideration. Some of the factors for adjudication of these of citations and ticketing is it has to be swift, has to be certainty, and has to be some severity of punishment. Potential problems are when there's advice that's given to citizens, or judges or judiciary making statements to the media, or saturating enforcement without notifying the court. So during these special emphasis times, that needs to be coordinated with the judiciary, that you're likely to see a lot more, action in your court, in a month or so when these tickets start, coming through the system. So just keeping them up to date of things that are going on. And then any change in the tolerance, could also be a potential problem. And setting speed limits differently in opposite directions. You know, if you're going northbound, the speed limit's this, and if you're coming southbound, there's a discrepancy in the speed limit. Those type things would be seen as potential problems where ticketing would be involved. So it's important to use crash data and that it be speed related as far as causation to a targeted or enforcement or a focus on extraordinary patrol efforts. And it's important to coordinate all these efforts with multiple jurisdictions whenever these, you know, those different lines are crossed in terms of whether it's, you know, state patrol or local police, and when local police can be on, you know, on state routes outside or how far outside the jurisdiction. All those things are important in terms of, you know, adjudication of tickets and citations. So we need to promote the need for speed reduction through positive enforcement efforts, through things such as whether it's targeting or whether it's education. We need to consider various speed detection technology devices that are available, and it should be used based on the project goals and local acceptance. Wherever there are whenever we're engaging with stakeholders, we need to be explaining our strategies for speed management and make sure they have a good understanding of what those strategies are and that they are, the benefits to the local community are shown. Because by and large, locals are, should be heavily involved in the speeding problem, because it's practically, in general terms, it is a local problem, local-based problem. There should be a technical process in setting speed limits, and certainly there are going to be judgments that will need to be made, and there are always going to be trade-offs in the policy and the political process. A lot of times when speed limits are changed, the impetus for those being changed were rooted in some type of you know, political or public official complaint. There are dynamics that affect setting of speed limits, whether it's, you know, the roadside environment, businesses, stakeholders, both residential, local law enforcement, and traffic engineering, and the judiciary all have a role in terms of speed management and working on speed reduction. And then also the driving population through, you know, public outreach and campaigns, media campaigns, a lot of different ways we can communicate to the public about what our overall safety goals are. When we think about the sheer number of fatalities that are occurring on our nation's roadways, we should be able to gain the ear of the general public in terms of our efforts and what we're doing to combat that problem. Some of the obstacles to speed management can be lack of involvement of stakeholders. If everybody's just kind of doing their own thing and there's not any coordination of the different linkages in the different areas, then that can be a problem. Lack of understanding of the issues, that's certainly a problem, because a lot of times enforcement doesn't understand the concepts of design speed and operating speed, and much less, you know, even those within the transportation community sometimes still struggle with those type issues as well. So anytime we can get everybody on the same page as far as understanding the goals and objectives of what we're trying to accomplish, we're going to be well ahead of the process. So lowering speed limits is not speed management. If we lower the speed limits beyond a reasonable and prudent speed, then typically we're going to be setting up some type of speed trap for, you know, enforcement to seize upon if they so choose to do. There can be a politically expedient response if we set speed limits too low. there can be resulting demand for increased enforcement, and particularly if the original problem has not been addressed. So lowering speed limits is not really a part of speed management. Doesn't mean that there aren't speed limits out there that need to be lowered, but that's not a way to achieve speed management. We certainly have speed limits out there that could and should be lowered, but that's not part of the strategy of speed management. Well, as far as how we should care about this, why we should care about this, 73% of fatal crashes are occurring on local and collector roadways. That's back in 2005. But this average, this figure hadn't changed a whole lot. Speed management is really a local issue. There should be a consistent approach and application of sound principles. So any public policy response, a framework should look like this. They should be appropriately set. They should be rational speed limits. They should incorporate engineering treatments, and there should be enforcement of the egregious violators, those in excess of the speed limit, whether it's a 7 mile per hour allowance or 10. Most enforcement agencies start at around 11 miles per hour in terms of issuing violations. Doesn't mean that's all, but should be targeting those most egregious violators. There should be targeted enforcement at crash producing locations, and there should be strong public communication efforts across the board between stakeholders. Coordinated response looks like this, where you're bringing everybody together. You have leadership, you have a champion for speed management, and policymakers have to examine their problems from all angles before taking their issues to the residents. So the primary goal in any type of coordinated effort should be to assess the compliance of drivers to rationally establish speed limits on target road investments. And secondarily, assessing the effectiveness of media campaigns and the effectiveness of enforcement campaigns on compliance. Those two should all be working hand in hand. So speed management requires it's a unified approach. It's a local issue requiring local solutions. So in a nutshell, I know that's a quick run through the stakeholders, policy, public policy, and enforcement side, but there is certainly a need of coordination. I've gained a lot of insight from just meeting with enforcement over the years, and they play a valuable role in both pointing out problem locations and identifying needs that have come to benefit public transportation agencies with suggestions and input that they provide. So with that, we're at the conclusion of the workshop. What I'm going to do, I'm going to paste in the chat area one last Microsoft Forms. If you would like to have a copy of a resource page that I've put together, then you can just fill out this Microsoft form. It's just simply provide me your email address instead of putting it in the chat pod and inundating these guys with more to go through. If you would, just send that to me, and you can use this Microsoft Forms. I'll post here in just a second. All I'm asking for is your email address there. So just provide that to me, and I'll be glad to send you this resource page. And before I send it out, I'll send it to folks there at LTAP just to make sure that they okay with me sending this out to everyone. So with that, Matt, I'm going to turn it back over to you and see if you have any thing you need to share with everyone.
Great. Right. So, Kim, one last question there. If you want to take a quick look at the chat box, that might be a good one to go out on. For everybody else, we have reached the end of the scheduled workshop. If you need to move on to other meetings, other business, lunch, whatever that may be, you won't be penalized if you step on out before we close things down. I want to thank everybody again for joining us today, and hope that you've picked up some useful information. I know I have picked up some things I didn't know along the way. So Tim, thank you for your effort and your time. Yeah, see some folks posting in the chat box there that they don't have permission to use the form. So one option I can offer, Tim, is that we will be contacting folks that were in the workshop to let them know they've received their certificate, or asking them to maybe watch some of the recordings to close the gap there and get that certificate. We can include the link, or actually the form itself, maybe with those emails. If you can send it to us, we'll be happy to help get it out to everybody.
Yeah, that would be great, Matt. It's just a one-page document with various links on it.
Okay, so we'll figure out how to get that to everybody. And then I don't know if you had a chance to pick it out there, but the question was about the use of multi-way stop control to control speeds, and what the current thinking is with that.
Yeah, I did see that. I'm not aware of it being used for that purpose. Typically there are certain certainly the recommendations for use of warrants for multi-way stops, but as far as it being used for speed control, I'm not aware of any. I think it's I think they certainly do. Depending on the approach, which the major road approach, two-way stop or whatever, converting to four-way stop, certainly have a impact on speed, but those would be very limited as far as overall operating speed along a section of roadway. But I'm not aware of them being used for that particular treatment. I've heard of signals being used for that treatment to coordinate speed and regulate speed along a corridor, but certainly that's done, but not a four-way stop.
All right, I think that's it for questions, unless I've missed one, or if you or Ayrton have received one, maybe via direct message. Did get a question about PDH certificates. So yes, just to make sure everybody gets the same information, we will be sending those out via email to everybody, 2 weeks or less, hopefully less, but we like to give ourselves a deadline. So. All right. So I think, yeah, looks like we've covered everything, Tim. So.
Okay. Well, thank you. Thank you for the work you guys did behind the scenes and putting all this together.
All right. I think it turned out well.
Thank you for your help. Yeah, thanks a lot. All right, Matt, I'll give a few more seconds here, and then I'll stop the recording and end the session.
All right, I've copied the chat box, so I've got all of the direct messages that came to me captured.
Okay. Yeah, I copied mine a little earlier, but should be fine with that.
All right.
All right, stopping the recording.